So we've got to make sure we test our numbers, like I said, into, I don't know what happened there, into F prime. We're going to check our numbers in F prime to see whether F prime is positive or negative, and F prime being positive or negative will tell us what F is doing versus increasing and decreasing. If I come over here, oops, I lost my 3. Okay. So let's say I test a -3 and a 0 and a 4. I've got a 3, x minus 2, x plus 1, and I can look at their product. You can also do this just by plugging -3 into the derivative in one big chunk, or you can use the factored form of the derivative. This is a little easier when you're doing it by hand. The 3 is always going to be positive. The x minus 2 factor is a negative with a -3, and it's negative with 0, but it's positive with 4. The x plus 1 factor is negative with -3. It's positive with 0. It's positive with 4. If I multiply these results together, I'll get a positive number when I plug in a -3 overall. I'll get a negative when I plug in a 0 overall. I'll get a positive when I plug in a 4. Lots of polynomials bounce back and forth between increasing and decreasing. So I'm going to see a lot of alternating. Not all the time. Please do not assume that that's what you have. Okay. There is a potential to get a critical number that isn't actually going to be a change. We'll talk, and there's a reason that that happens. Okay. So where you can expect to see a lot of alternating behaviors, don't just make the assumption that's what you're going to see. Rackable question.
So for the test formula or the equation, which one should we use? Should we use the f of prime?
Use the f prime.
So like the 3x squared minus 3x minus 3.
Yeah, you can use it in this format, or you can use it in factors. I'm showing using it in factors because I'm kind of doing it in my head. I'm doing each little piece. I'm not typing it in a calculator. But if you wanted to use a calculator, yeah, -3 in here for both of these x's. What kind of answer do you get? Positive or negative? 0 in here for the x's, you get a negative answer. 4 in here for all the x's, you get a positive answer. So what do these results tell us? Where is f increasing? Say that again. Negative infinity to -1. 2 to positive infinity. Right, let's go ahead and grab this real quick and put this on the next page. So when we look at the number line, it really kind of is not super useful unless we understand what it's telling us. These pluses and minuses above these different chunks of numbers on the number line basically are telling us slopes. Right? So I know f has a positive slope from negative infinity to -1. That's what that plus sign is indicating on the number line. Positive slope, f prime greater than 0, increasing. Okay. So overall, I know f is increasing from negative infinity to -1 and then again from 2 to infinity. And then f is decreasing on the interval from -1 to 2. So if we were going to look at the graph of f, it goes up, then down, then up. And this turn right here is at -1. And this turn right here is at 2. I don't have any y's indicated, but I know it goes up, then down, then up, increasing, then decreasing, then increasing, with a turn lining up with -1, and then the next turn lining up with 2.
Is that the type of brackets to where square brackets won't be straight?
No, polynomials aren't going to have a section where they're straight. Okay, the only way we're going to get a section that's straight is if we take our function and we have a function that's kind of that's determined, it's like a piecewise function. So that would be a place where we would have a constant. Okay. All right, how we doing? Yeah? No? Sort of? Raylan, question? Okay, I don't think 0 is a critical number for this problem because 0 is not a number that makes this derivative equal 0, unlike this derivative. See, this derivative, when I plugged in a 0 for x into the derivative, I got 0. That told me 0 was a critical number or 0 was a place where there was a term. Because neither my critical numbers are at 2 and -1, I know that's where the turns are. So that's where the transitions are between increasing, decreasing, or decreasing, increasing. Yeah, okay. And if we, and this is always kind of like our fallback position, but you have to make sure you're looking at the right thing. All right, so this was the derivative. All right, so there's the cube minus 3 halves x squared minus 6x. Okay. Delete. So this was the original function. And so we can see it's got the turn here at -1, and it's got the turn at 2, and it's going up and then down and then up. So it doesn't have a turn at 0. That, yeah, okay. You're welcome. All right, if we look at the next one. Okay, so my derivative this time is 4x cubed minus 6x. Okay, 4x cubed minus 6x. Oh, crap. Yeah, this one's no fun, but that's okay. We can still do it. Sure. Okay, there we go. All right. All right, how are we going to find critical values for this? Factor, what should we factor out? An x, and what else? A 2. Okay, so a 2x will leave me with a 2x squared. Oh, yeah, this is really gross. This one's going to be really gross. Okay. This is kind of good though, because this is a perfect, it's not a pretty answer. That's kind of what I mean when I say it's gross. And this is actually the kind of problem where, you know, the calculator isn't going to give you the precision answer that the calculus will. So, here we go. 2x equals 0 means that x equals 0. So that's one of my critical numbers. How many critical numbers am I going to get? Let's look at this. This is a 4th degree polynomial. So chances are 3 turns, 3 critical numbers. My derivative is a degree 3. So 3 zeros, 3 x-intercepts most likely. How are we going to solve that? Okay, so 2x squared minus 3 equals 0. Now what? Okay, so 2x squared equals 3. So x squared equals 3 over 2. So what does x equal? Plus or minus square root of 3/2. Ooh, fun. Okay. This is all still number 3. All right. 0, yay. That one's easy. Plus or minus the square root of 3/2. You might be thinking like, well, what the heck? I don't know what that is. So how am I supposed to put that on a number line? Well, we can estimate it. 3/2 is bigger than 1. The square root of 1 is 1. So the square root of something bigger than 1 should be bigger than its square root. So this is definitely a number bigger than 1, but probably not all the way to 2. Because this would have to be a 4 under here for the square root to be plus or minus 2. So this is somewhere between 1 and 2. All right. So let's make a number line. 0, square root of 3/2, negative square root of 3/2. So 2 and 1 should be on either side of it. Those would be good test numbers. I know the square root of 3/2 is less than the square root of 1. But it's bigger than the square root of 4 because 3/2 is between 1 and 4. 3/2 is 1.5. It's a little bit bigger than 1, but it's not as big as 4. Now, my f prime here, woo, 4x cubed, what's 4x cubed minus 6x, or 2x times 2x squared minus 3. Oh, I already made a number line. I don't need to do that again. Here we go. I'm going to do a -2. I'm going to do a -1. I'm going to do a 1. And I'm going to do a 2. 2x. 2x squared minus 3. Final result. Once again, this is me doing the analysis without a calculator. with a calculator, you can much more easily evaluate 4x cubed minus 6x at different values. You can throw it in to a y equals on a graphing calculator, 4x cubed minus 6x, and check out a table, and you can very easily see what kind of numbers you're going to get for positive and negative 1 and 2. The 2x part is easy. Put a negative number times 2 and you're going to get a negative. Put a positive number times 2 and you're going to get a positive. This guy's a little tougher. Let's see, a negative 2, that's going to be a positive. And negative 1, this guy actually jumps back and forth. So it's going to be negative, positive. Oh, look, it toggles. It goes back and forth between negative and positive. Okay. It's a lot of analysis right here. There's a lot of math, arithmetic work. This is usually where in AB we really cry a lot when we don't have our calculator. Okay, that's where in applied this is a little bit better because we do have a calculator to, even though we're going to do the process using calculus and not by looking at a graph, we can complete the numeric analysis. We can determine the plus and minus, the positives and negatives through some substitution, as long as we're pretty savvy with our calculator. Another thing you've got to be careful of is when you are using your calculator and putting like a negative 2 in and cubing that, and or putting a negative in square, whatever you're doing, you've got to watch how you're using those exponents. So some of your skill with your calculator here is going to kind of determine how successful you can be with this. Okay. After all of that, here's what we've determined. Well, let me ask you. Where is f of x increasing? Negative root 3 over 2 to 0. And right. And then because we are doing so many polynomial functions, we are bouncing back and forth between increasing and decreasing. So my decreasing from negative infinity to negative root 3 over 2, and from 0 to root